Have you ever really thought about what happens to rock right after it's been mined? It's not like you can just use it straight away. So in this explainer, we're going to dive into a really fundamental engineering challenge. What in the world do you do with the messy stuff you're left with? Sometimes it's a fine, dusty powder. Other times it's a wet, sloppy slurry. Honestly, both are a massive pain to handle on an industrial scale, so let's check out how engineers solve this puzzle.
Okay, so here's our roadmap. First, we'll get into why this superfine dust is such a headache to begin with. Then, we'll look at the clever ways we can stick it all back together. After that, we're going to flip the script and tackle the opposite problem, materials that are way too wet, and explore how we get all that water out.
All right, let's kick things off with problem number 1, dust. You see, to get to the valuable minerals, you have to crush just tons and tons of rock. And the side effect of all that crushing, you end up creating mountains of these tiny, fine particles.
And that really is the million-dollar question, isn't it? It might sound simple, but figuring out what to do with these fine particles, or fines as they're called in the industry, is a huge industrial challenge. It takes some seriously clever engineering to get it right.
You see, the big issue is that these tiny particles are just plain inefficient. I mean, imagine trying to roast them in a furnace. The powder is packed so tightly that hot gases can't even get through. Or a strong gust of wind could just blow your valuable product away, which is not only wasteful, but can be an environmental problem too. Bottom line, they're a nightmare to work with.
So if your particles are too small, what's the most obvious solution? Well, you make them bigger. The fancy engineering term for this is agglomeration, which really just means we need to find a way to get all these tiny particles to stick together and form larger, more manageable chunks. Okay, one of the most common ways to do this is called briquetting. And you've probably seen this before. If you've ever used charcoal briquettes for a barbecue, you've seen the final product of this exact process. It's all about squishing fine material into these nice uniform lumps.
And this diagram shows you exactly how it works. It's actually pretty cool. You see the fine particles, the dust, getting fed in from the top. They fall right into the gap between two big rolls that are spinning towards each other. These rolls have these little pockets carved into them that act like molds. And as they turn, they squeeze that powder with a ton of pressure, compacting it into those little briquettes you see falling out the bottom. It's a really simple, continuous process that just works.
So what's the secret sauce here? Well, it's a binder. Something like lime or clay or even tar that acts kind of like a glue. You just mix a little bit of that in with the fines, compress the whole mixture into whatever shape you want, and then you let it harden, either just by air drying or by giving it a bake in a kiln.
But, high-pressure squeezing isn't the only way to do this. The next method is less about brute force and more about, a gentle rolling motion. The best way to think about it is like making a snowball. You start with a small packed core, and as you roll it around, it just picks up more and more snow, getting bigger and bigger.
And this right here is the industrial version of that snowball effect. You're looking at what's called a disc pelletizer. Check out that side view. Fine, slightly damp particles get fed onto this huge, rotating, tilted disc. As the disc spins, the particles just start to tumble over each other. They collide, they stick together, and they roll, and they gradually grow into these almost perfectly uniform little spheres or pellets that eventually just roll right off the edge when they get big enough.
So, unlike briquetting, the key here isn't intense pressure, it's controlled moisture, usually right around 10%. That little bit of water makes the particles just tacky enough to stick together while they're rolling around. A little bit of binder helps too, but the real magic happens at the end. These green or unfired pellets are then sent into a furnace and cooked at insanely high temperatures. This hardens them into these really strong, durable, almost ceramic-like balls.
Okay, so we figured out how to handle dust. But what about the opposite problem? What if you have a wet slurry? This happens all the time after certain chemical processes where ores are mixed with water. And that brings us to our next major challenge, dewatering. And there are a ton of reasons you'd want to do this. Sometimes you need the recipe of solids and liquid to be just right for the next stage of the process. Other times, you just want a solid product at the end of the day. And this is a big one. Sometimes that liquid has valuable stuff dissolved in it that you want to get back. Or maybe you just want to recycle the water itself. So how do we actually separate the solids from the liquids? Well, the first strategy is probably the simplest one you can imagine. You just let gravity do all the work for you. In industry, we call this sedimentation, or thickening.
And this shows the basic principle in action. It's so simple. You take a slurry, put it in a cylinder, and just wait. Over time, the heavier, solid particles will settle to the bottom, leaving a layer of clear liquid. We call that the supernatant right on top. It's exactly what happens when you let a glass of muddy water sit on the counter.
But settling isn't always a steady process, and this graph shows us why. See how the line for the mud drops really fast at the beginning? That's when the particles are basically in free fall through the water. But then, as they start to pile up on the bottom, the settling rate slows way down. That's called the compaction phase. Now, the weight of the particles on top is actually squeezing the water out from below, but as you can see, it's a much slower process.
Now, to do this on an industrial scale, we use these absolutely enormous tanks called thickeners, like the one you see here. The slurry gets fed into the middle, up at the top. As it flows outwards towards the edge of the tank, the solid particles have time to settle down to the slope bottom. At the same time, all that clear water rises to the top and spills over the edge into a channel. And down at the bottom, you have these big, slow-moving arms called rakes that gently push the thickened slurry towards the center so it can be pumped out. It's basically that glass cylinder from before, just scaled up into a massive, continuously running machine.
But, sometimes gravity just isn't fast enough or it doesn't get the solids dry enough. To take that next step, we need to apply some force. And that brings us to our final dewatering technique, filtration.
The idea here is exactly the same as your coffee maker at home. You have some kind of filter, in this case an industrial filter cloth, that lets the liquid pass through but stops the solid particles. You then apply pressure to the slurry, which forces the clear liquid, we call that the filtrate, through the cloth. All the solids get left behind, and they build up into this layer that we call the filter cake.
And to do this on a huge scale, engineers have come up with a whole gallery of amazing machines. For example, this is a rotary disc filter. You've got a bunch of discs covered in filter cloth, and they rotate through a tank of slurry. A vacuum on the inside of the discs sucks the water through, building up that cake of solids on the outside.
Or you have something like this, a horizontal belt filter. This one works pretty much like a conveyor belt, except the belt is made of filter cloth. You pour the slurry on one end, and a vacuum from underneath pulls all the liquid out as the belt moves along. By the time it gets to the other end, you're left with a nice, dry cake of solids.
And finally, when you have slurries that are really hard to dewater, you've got to bring out the big guns. This is a plate and frame filter press. The best way to think of it is like a giant automated accordion. Slurry gets pumped into the spaces between all these plates, which are lined with filter cloth. Then, a massive hydraulic press squeezes the entire stack together, physically forcing the liquid out. It's kind of like wringing out a giant sponge with a ton of force.
And all of this brings us to a final thought, one that pretty much every engineer has to wrestle with. You see, getting a perfect separation between a solid and a liquid is practically impossible. Or, at the very least, it's incredibly expensive. The drier you want your solids to be, the more energy you have to use, and the more complex and expensive your equipment gets. So the ultimate challenge is always finding that sweet spot, balancing how well your process works with how much it's all going to cost. And really, that trade-off is at the heart of so much of what we do in engineering.